Chapter 2, Section 3, Question 1. Complementary and supplementary angles. So, from in geometry, complementary angles are two angles that add up to equal 90 degrees. Those two angles do not necessarily have to be next to each other, and they don't have to be equal to each other either. Supplementary angles are two angles whose sum is 180 degrees, and again, they don't have to be next to each other, they just have to add up to be 180 degrees, and they do have to be only two angles. So I'm going to tell you that angles A and B are complementary. That means that they add up to equal 90. Angle A is 5 less than 3 times the size of angle B. Angle A is 5 less than, remember from chapter 1 that less than means we're going to switch the order of that. 5 less than 3 times angle B. I'm going to use X for angle B. Some students want to use B for angle B. That's fine. Some people want to be tricky and use A for angle B, and then they get themselves confused. Don't do that. So, angles A and B are complementary. We're going to add these together. There's angle A. There's angle B. They add together to equal 90 because they're complementary. We're going to combine like terms and solve our wonderful little two-step algebra equation. (95) divided by 4 goes in there 2 times. 4 times 3 is 12. And we will get 4 into 30 gets in there 7, 28. And 5. That's going to be X equals 23.75. Oops, 0.75. There we go. But wait, there's more. We also have A. A is 3x minus 5. 3 times x minus 5. You might want to, on the side, do 3 times x, so 3 times 23.75 minus 5. 3 times 23.75. 23.75 times 3, 15, 22, 11, and 7. Minus 5 still. So if we have 71.25 minus 5, that would give us 66.25. And this is 66.25. X is 23.75. And if you really want to do a quick check, add these two together, and it will give you 90. Now, some students do 90 minus 23.75 and get this. But if you actually multiply and subtract, and they still give you 90, that's going to be the right answer. If you find that these don't add up to equal 90, you may have made a small algebraic mistake or arithmetic mistake. Now, you'll notice that I wrote this lovely answer box in the same order that I wrote my variables, first and second, first and second. That way when I write my answers in here, I have them in the correct blanks. Many students do not have these in the correct blanks, in which case you're still going to lose points. Notice that over here I put this little degree sign. That is for the measurement of an angle. Chapter 2, Section 3, Question 2. Angles in a triangle. The angles in a triangle add up to equal 180 degrees. This is something from geometry in case you did not have geometry. So here, a triangle has 3 angles in it, and I'm drawing a generic triangle. Angles A, B, and C, we're going to be looking at the corners, which are the angles. Those are the 3 angles. Angle A is the smallest angle. Obviously, my picture is not correct. Angle A is the smallest angle. I'm going to make a little note here, SM, that that's the smallest. Angle B is 15 more than angle A. Angle B is 15 more than. Remember the phrase more than or less than says switch the order. So it's going to be x plus 15, which means angle A is x. Angle C is for more than, that phrase again, twice the smallest angle. You remember the smallest angle is A, which we're using X. So it is for more than twice the smallest angle. Now that I have my lovely picture, which in geometry often helps us, we're going to have angle A is X, angle B is X plus 15, angle C is 2X plus 4. And we know that in any triangle, the sum of the angles is 180 degrees. At this level of math, because some of you have not had a geometry class, I am going to tell you this fact. So we're going to have a sum, the first angle plus the second angle plus the third angle. Some students want to put parentheses around this so that they can see the first, second, and third angle, but then remember you'd have parentheses, and then without parentheses, then combining like terms, and this adds up to equal 180 degrees. We don't have to put the degrees here, because while we're solving our math, we don't want to put that in there, and that gives us 4x, 15 plus 4 is 19, equals 180. Subtract 19 on both sides. Now, we can definitely do this by hand. However, for speed of lecture, I am going to do 180 minus 19 and get 161. And dividing both sides by 4, we can definitely do that by hand. I'm going to take that and divide it by 4, enter, and we get 40.25. Now, we have x, but we also have x plus 15. But wait, there's more. We also have 2x plus 4. So, x plus 15. We have 40.25. I can put store in for x, and I can then put in x plus 15, and that will tell me that that is 55.25. And then I can also do 2x plus 4, and it will tell me that that is 84.5. To double check, I can also take 40.25 plus 55.25 plus 84.5, and it equals 180, just like it's supposed to. The 4 parts of our word problems are define the variables, write the equation. Just these 2 pieces right here are enough to get you half credit. Solve the equation for all the different variables. So I do need you on the right-hand side to find all 3 of them. If you only find one of them, you're going to lose points. And then, over here, we have the same answers, 40.25 degrees. We have 55.25 degrees and 84.5 degrees. Make sure you label all of them. Chapter 2, Section 3, Question 3. The sides of a triangle. Now, triangles can be of many different sizes. So while the angles can have rules about them, the lengths of the sides are a little bit different. There is an important rule that we'll deal with in other classes, that if you take the small side plus the medium side, it has to be greater than the largest side. This is called the triangle inequality. And so what this says is that if it's not greater than your small side and your medium side, if it is less than or equal to the large side, they won't be long enough to hit each other and you won't have a triangle. So that's an important thing to watch out for, but we're not dealing with that in this class. We're just going to solve this word problem. Here again we have A, B, and C, which are angles in our triangle. We have AB the side, BC the side, and AC the side. The perimeter is 8 centimeters. Perimeter means the sum of all 3 sides, or all of the sides of any figure that has straight sides. AB is the shortest side. Cool, we're going to make a note that this is the short side. All right, BC, this length is 3 more than twice AB. Remember, these phrases, more than, 3, more than, twice AB. Some students want to use 2AB. I don't want you to use 2-letter variables. X is for AB, so X is our shortest side, AB. AC is 1 less than and more than, switch the order around. So it's 1 less than twice AB. Now that we have that, we're going to put the variables in here from our picture. Pictures often help when you are doing geometry. So we have x here. BC is 2x plus 3, and AC is 2x minus 1. The perimeter, if you add up all the sides, you'll get 88 centimeters. I am going to move this up here so I make sure I have enough room. I have x, the first side, plus 2x plus 3, the second side, plus 2x minus 1, the third side, is equal to 88 centimeters. The variables and the equation, that is half of your credit right there. But wait, there's more. We're going to combine like terms. X and 2x gives us 5x. 3 minus 1 is 2, equals 88, minus 2 on both sides. Divide by 5. And 86 divided by 5 is 17.2. We have x and 2x plus 3 and 2x minus 1. I'm going to take my 17.2 and store it in for x, enter. And now that x is 17.2, I have 2x plus 3, enter, and 2x minus 1, enter. And that will give me 37.4 and 33.4. If I want to double check, I can add those up together and it will give me 88. But wait, we have variables, we have equation, we have solving for all of our variables, and over here we want x first is 17.2. That's labeled in centimeters. This is labeled with centimeters. Many students, since all the other problems were labeled with degrees, will label this with degrees. BC is 37.4 centimeters, and AC is 33.4 centimeters. Now, box is lovely answer block, because we want to make sure we have all of those answers. Chapter 2, Section 3, Question 4, Using Percentages. This is a popular problem because it's, again, a lot of how real life works. A student wants to spend $25 on a TI-83 Plus calculator for a class. There's a sign advertising 20% off of all electronics. They're obviously not going for a brand new one, they're going for a used one, which is totally fine. What is the maximum original price the student should look for? Now, many students know that if you were to buy, for example, a calculator for $100 and you had a 20% off, and remember that 20%, you would put it into your equation as a decimal, that you would then have to pay $80. However, if you look here, you're missing something. We have to have our $100 here. Normally, when we write an equation, we don't have the dollar signs in there. $100 minus 20% of the original $100 equals $80. Many students forget to put this, in which case they only take 20 cents off, in which case 20% off would give you $99.80. In which case, I will sell you a $100 calculator at 20% off. And you can pay me a lot more than you're supposed to. So the formula for this is the original amount minus the percent times the original amount again is equal to the new amount. This is a formula that is very useful. So here, what was the maximum original price? X is our maximum original price. X is one of our favorite variables. So our original price, X, minus the percent. In this case, 20%. Remember the 0 in front of the decimal, times the original price again, is equal to the new price, which is going to be $25. There's an invisible 1 in front of here. So this is 1x minus 0.2x, which gives you 0.8x when you combine like terms. So be careful about that. Dividing both sides by 0.8. And you will get 25 divided by 0.8. We can definitely do that by hand. But that would give us 31.25. So variables, formula, solve, and answer 31.25, but it's not done until we label it as money. Chapter 2, Section 3, Question 5. I have this because this has happened before. So let's say that you say, hey, mom, brother, sister, dad, uncle, somebody that you like. You say, hey, I'm going to take you out to dinner or lunch. And you get there and you realize that you forgot your wallet at home and all you have is $40 in your pocket in cash. So you can either say, hey, whoops, could you lend me money for the lunch or dinner that I have told you I would pay for, which they probably would. But to save embarrassment, we're going to try and make it fly without. So the thing is you need to know how much you can spend on the menu so that $40 is enough. So here, there's sales tax. You have to pay tax on food at a restaurant. And at most of them restaurants, you also leave a tip. 15% is for average service here in Colorado, 20% for good service, 10% for not so good service. If you were on the east or west coast, that usually goes up by about 5%. So here, we could write this out as a very long problem. So you would have your meal. Here is your meal plus their meal. And then you would add on the tax onto your meal, which is 0.073. Be very careful with this. We're dividing it by 2 zeros. We have to move it over 2 places. That's why it's 0.73. Many people move it over only in one place, in which case they're paying 73% tax. That's difficult. And times by the original. This is the meal plus the tax. Then you're going to leave a 15% tip. Here's the 15% tip on the meal plus the tax. Technically, this is not correct. However, more and more nowadays, this is how tip is calculated, is the meal plus the tax. And that has to equal our $40. We can combine like terms here, and we can combine like terms here. This will give us 1.073x, which is the same as this 1.073x. This is here one time, and we're going to use factoring, which means since they both have a 1.073x, we're going to have the 1.073x, and what's left is 1 plus 0.15, which is 1.15, equals 40. That's a lot of work. Myself and some of the other math teachers have gotten together and we said, hey, we can actually make this a lot shorter, and we're going to allow you to just start off with a 7.3%. You're going to have 1.073. The 15%, you're going to have a 1.15. And you're also going to have your x equals 40. Notice that we put these into separate ones. That makes it a little easier on you. You could multiply it together and divide it across. You could also, because of our amazing calculators, divide each of these, just like we divided by the length and the width in a previous problem. We can divide by these. And solve for x. What you're going to type into your calculator is 40 divided by 1.073 divided by 1.15, and the calculator will actually do it correctly. If you have the ability to make a numerator and denominator like this, that would be wonderful. So 40 divided by each of those gives us 32.41622432. So interesting thing here. technically, you can spend 42 cents because of rounding. If, however, you are not able, you had to stay within your 40, then you would not be able to round and you would have to only go with 41 cents. We are going to assume that since, as long as you're really close to the 15% tip, they're not going to say no if you're 1 penny more or less. We are going to round it correctly. And so you can spend $32.42. But wait, this is not where we write the answer with the label. It is down here. And we want our $32.42. Now notice, some of your $40 is going to go to paying tax and tip, but not all of it. Most of it is going to your food. So, if you are eating with your friend, your mom, your whatever, then if they say, hey, oh my gosh, I've always wanted to try the $30 special, then you're like, hey, I have decided to go with the $2 side salad. Have a great meal. It's all about you. If, however, they say, hey, I'm going for the $15 burger, you're like, hey, I'm also going for the $15 burger. And if they say, hey, I'm going for this $10 special, then you can say, hey, I'm going to go for this $20 thing that I really wanted to have. Awesome. And do this. One of the reasons that we're doing it this way is because if you are in this situation, you could suddenly, on your calculator in your phone, do 40 divided by this, divided by that, and see what that answer is. Very subtly, because we do not expect you to get out a napkin and do all of this work in the middle of a restaurant while you are having a lovely dinner with whoever you are treating out.